Hi everybody, so my name is Amélie Cordier. I'm the Chief Scientific Officer at Hoomano. So today I will talk about what I see as the next challenges for AI provided by social robots. So before that, I will just introduce the kind of activities we are doing at Hoomano, and then we'll dive into details, not many details. So Hoomano is a startup developing software for social robots. So what is a social robot? It's a robot that doesn't do anything. It cannot hold a water bottle for you, for example. Its only role is to communicate, to exchange information. So it's a robot that is able to speak, that is able to listen to you, and that will provide you information or services or entertaining. So our main customers are retail, hosting, and even elderly people houses. The main robot we are working with is Pepper. Some of you may know about this robot, but we also develop technologies for other robots. Usually when we think about robots, we think about industrial robots, robots that are doing tasks such as identifying pieces in a chain, grasping objects, and so on. When you work with social robots, you are more interested in different types of problems, namely the problems of being in the real world. And this makes things very complicated. So for example, one of these problems is navigation. If you think about autonomous vehicles, for example, navigation is not really an issue. But if you think about a social robot, which mission would be, for example, to provide you information in this room, you see that the challenge is quite big. There's stairs, people moving around, and so on. So as a consequence of that, one other application domain for such robots is unpredictable environments, either because they're full of humans, and humans are a pain for robots, let's say it, or because we want to send robots in environments that we cannot model at the beginning, because we don't know how to represent those environments, such as, for example, external planet exploration or disaster exploration. But maybe the most difficult task for social robots is interacting with humans. Because humans is, I guess, the most complicated thing to interact with in our world. And I have a proof for that. Interacting with you, for me, is quite complicated at the moment. I have many things to deal with. I have this thing that I'm afraid to make fall. I have this guy working with a timer that is still not working. I have you trying to laugh politely at my jokes, and I have something to tell you. And I have to manage all these different issues at the same time. You see that it's quite a big problem for a robot. So human interaction are quite complex interaction, and at the moment, even if we pretend to put robots in real life, to be honest, we don't have a clue of how we want to interact with these robots. So for me, and I will just give you a few hints about that. For me, learning what we want in the way we want to interact with robots is a crucial issue for one simple reason. Technology is everywhere. You all agree with that. Artificial intelligence is everywhere and will be everywhere in the future. And the way we want to interact with artificial intelligence has to be defined now. So working with robots is a good way to investigate, to discover what works and what is not working when we try to interact with robots. And for those of you who were there this morning, Antoine Bord told it very well. Natural language is one way of interacting with technology, because natural language is available for most of us, not to say all of us. But natural language is not the only thing. Non-verbal communication, all the interaction codes are also very important in designing a proper natural interaction with a piece of technology. So I think working with robots today, even if it's not really working properly, is a good way to learn what we want for interacting with technology tomorrow. So the question is deep learning a solution to teach robots to interact with people? And so usually people tell me that, yeah, you know, deep learning makes huge improvements at the moment and you should investigate it because it's a solution to every problem. But again, if you follow the talk this morning, you will know that, yes, the results are quite cool, But to be honest, there's plenty of problems remaining to solve. So, for example, the data issue is a very important data. We do have data, we can learn good models from data, but it's not everything, and data has a limit. Even if we can create some data, and I will speak about that a little bit later on. Second issue I find important with deep learning when you want to apply it to social interactions is that deep learning can easily be fooled. Okay, you can fool a system, making it think that you are showing a picture of a pineapple while a human eye would recognize that it's a cat. Okay, so that's a very important thing too that we have to take into account. And for me, the most important part, the most difficult issue deep learning has to tackle at the moment is the lack of generalization ability, abstraction ability, and to say it in one word, common sense. For example, if a robot has to see the picture that you see on the right side, this cat trapped in blinds, at the moment, no system could have the common sense to understand that this is a problematic situation that we want to solve. So we have many steps to go through in AI in general, and thinking of deep learning is not the only option. So if you want to counter-argue to that, you can say, yeah, but the data problem is not a problem because now we know how to generate data. So we can train models on very complex data sets so we can address more complex problems. Yeah, I agree. But can you model with artificial data the social interactions? I don't think so. Others could say that there are many alternatives techniques and many combined techniques in deep learning, such as transfer learning and so on. I won't, deep reinforcement learning, for example, and I won't go into details, that are actually good ways to improve the abstraction and generalization strategies for deep learning algorithms. But again, I think it's not the solution. You could also say that devices, the two things you see on the right, which are the Turing chip for NVIDIA and the Movidius key for Intel, are trying to address the performance issues of deep learning by implementing hardware that is able to process computation much faster than what we can do at the moment, and this is a solution. Yes, this is a part of the solution, but I think it's not enough. So I think we have to address many other ways of doing artificial intelligence to improve the performances of the systems we develop. And the field I'm interested in is called developmental robotics. And to say it short, developmental robotics is a very old artificial intelligence technique that is inspired from the work of a psychologist called Jean Piaget, and which draws inspiration from the way babies are learning by interacting with the environment. So the idea is to create systems that, instead of learning from a data set or from supervision for a human, learn because they want to learn. They are intrinsically motivated to learn because they are interacting with their environment, and when the interaction is successful, then they have an internal satisfaction that drives them to learn further. So the important keywords in developmental robotics are curiosity, because if we want a system to be able to learn, then it has to be curious about the environment. Intrinsic motivation, as I told you before. For me, embodiment is very important. The fact that the robot or the AI has to have a body so it can interact with the environment, and the ability to interact with this environment. So just to give you a very short example, at Hoomano, we are implementing this kind of artificial intelligence, a kind of side artificial intelligence, to learn how to interact with people. And we are not trying to learn vocabulary. We are not trying to learn common sense things. We are just trying to learn how the guy in front of us wants to interact. So in this example, for example, we are just using the feedback from the user to learn if the robot speaks fast enough or slow enough, depending on the behavior of the user. So I think that's a very interesting field to explore. Just to conclude, what is important for me in studying developmental robotics is that it's a different AI strategy that enables us, because we are focusing on the agent motivation, to learn with less data. And I think that's something we should take very seriously. We hope that it will enable us to better understand social interactions, because social interactions is a typical kind of problem that you cannot model, so we have to learn it a different way. As I told you before, I strongly believe that embodiment is very important when you focus on developmental learning, because you have to focus on how the robot or the agent is able to build its own representation of the environment depending on what it actually can do on the environment. And to finish on a more maybe ethical question, I think it's not always because we can that we should. And it's not because we have a lot of data that we should use deep learning. It's not because we have a lot of computational power that we should use it. And maybe we should sometimes use our brains to find alternative solutions to existing problems. And if it works, maybe one day we can teach our robots instead of training them. Thank you.